this power supply is small enough that it can be built right into existing equipment. It can be just the power supply in equipment. However, of course, we don't want it to be permanently in there because we have a lot of uses for them. So what I wanted to do was just show an application where we could have it used in an instrumentation system and still be flexible enough to be used elsewhere. I'm set up here to make a power cable for something that uses a barrel jack to connect power from my Tenma power supply. So the first thing I'm going to do is tin the wires using my Tenma digital soldering station, and I'm going to use the Tenma fume extractor here while I'm soldering. So we put some water in the sponge, turn that on, and I'm just going to tin the wires. I'm only tinning the black one here because I want the red one to remain flexible. And here's our little connector. I think maybe I'll tin that too. I think maybe it needs a little flux, which will make it pretty smoky. Hard to do this in a way that the camera can see it. This is where I want the red wire to be flexible so I can flatten it out in the little cup. Okay, I think that's all the soldering I need to do. Have to cool this off. I'm just going to crimp this little connector onto the wires. And I'm going to put a little piece of heat shrink over that. Okay, I had to take it over to my other soldering station to shrink the heat shrink tubing. Let's just measure the continuity here with my handy Tenma digital multimeter and a handy power button, and it's an open circuit, which is great, just to make sure the meter's working. So that's good. Now we can put the little barrel onto the connector. Hopefully it'll fit through that, over that heat shrink. That's one end of the cable. Got a nice little strain relief on the heat shrink. The other end, we're just going to put on these banana jacks, which use screw terminals. Use my Duratool screwdriver. Try and create enough room in there for the wire. Looks good. And the black one. There we go. So a nice little power cable. It'll just plug into the power supply like this. And let me get set up to show you what this plugs into. So what I have for this application is a Dymo label maker. This label maker has a battery compartment which has 6 AA batteries to get 9 volts, and it's just a real pain because as soon as the batteries drop below 9 volts, this thing doesn't work. And so I'm always changing batteries. They seem to last for just one use of the device, making a few labels, and then the batteries die. But it does have a power jack here that can take 9 volts, and they request 2 amps. So this power supply can certainly supply that, and it would get me away from having to replace batteries all the time. So this is a portable instrument, of course, and we would like the pair to be portable instead of having to drag around a bunch of cables and connect them up like this. I wanted to build them in, so I built a carrying case for the label maker, which is pretty tight to get it all installed here. Have to make sure that the feet are actually coming through these slots so that they can actually rest on the table. And there we are, fully inserted. For the Tenma power supply, I have a different kind of a carrying case. So there are a couple of features on the back which protrude a slight bit, and there's some pockets in the case here to accommodate those. But it just slides in quite snug but not tight. And I have a little cap that will prevent it from sliding out the top. So this has some teeth on it to grab in, and you'll be able to hear how tight this is by the sound it makes when I put it together. So it's on there fairly snugly. It does come apart quite easily, but it's not going to come without some persuasion. I've taken it apart a bunch of times, so it does come apart quite easily. And of course, if we don't want it to come apart, the cable actually locks this in place. So if I plug this in, it can no longer come apart. So the power cable is actually the lock. And I've extended that idea so that when I put these together with a big handle, which is 3D printed again, so I'll just slide the think. Slide the handle. Oh, it's the wrong way. Slide the handle through here. It goes in easily. Slide the handle in here, so we have an instrument that we can pick up with a handle, and the handle gets locked in, also gets locked in by the power cord. So once the power cord is in there, the handle no longer comes apart, and it can just be picked up and carried around like a single instrument. And of course it fits in a briefcase if you like. I happen to have a case that used to hold a chemical sensor, and it fits this thing quite nicely. So we have room in here for the power cord. I haven't bundled it up well, but it fits in there quite easily. And now I have a fully portable instrument package. It's nicely held in place by the foam. And I can just pull it out, plug in the power, and away I go. So that's just a demonstration of one way you can build this power supply into various applications. In this case, it's very handy because I want to be able to be mobile with my Dymo labeler, and it takes enough power that I really want a power supply and not just to be running off batteries. An excellent application for such a small power supply. Okay, I almost forgot to demonstrate this thing in action. So if I turn on the power to this cord, the power supply starts up, and I've got it in a mode where it's 9.2 volts at 2 amps, which is kind of what this thing needs. If I turn on the output, then I turn on the power to the printer, and I've entered in element 14 as some text, and I can print that. And let's just take a quick look. The power is jumping around at half an amp. So it's not taking the full 2 amps, but I've tried this with a 1 amp setting and it's not enough. So it needs to be somewhere around 2 amps maximum. And there's a slot in the top here to get the printed text out. And there it is, element 14 from the printer. And my nice little instrument is ready to go. It's all portable. I can take that anywhere.